Buddy, and welcome to another Geo-Institute live stream. Today, it's GeoStrata Extra, the thing that we do every time we put out a new issue of the magazine. My name is Brad Keeler. I'm the director of the Geo-Institute, and we are thrilled to have you here for another episode of GeoStrata Extra. If you don't know anything about the Geo-Institute, after you watch this today, you should head over to geoinstitute.org, and there you will find out very many things about our fine organization, including that we are a technical society with about 12,000 members, most of whom are geotechnical engineers and/or geologists, and that we are part of the American Society of Civil Engineers. If you like what you see today, and we will do our darndest to make sure you do, you should click like, subscribe, and get notifications, and we will let you know every time we post something to the YouTube channel. Of course, this is GeoStrata Extra. What is GeoStrata Extra, you ask? Every time we put out one of the issues of that magazine, which is 6 times a year, we try to take you behind the article, an interview with one of our authors by one of our editors. And today it's on reusable foundations. We'll get to that in just a minute. Another website that you can go to if you wish to check out the magazine and you do not have it in your hands right now, you can head over to readgeo.com. And when you go there, you will see something like what is on your screen right now. You can click these arrows and you can go through the magazine as if you had a physical copy right there for yourself. Page view, it's beautiful when it actually loads quickly. Look at that. You can go back to the issue library and you can read several years of back issues as well. So be sure to do that after you watch us today. Now, we do have a sponsor today. We are very excited about that. We thank GeoPeer for their generous sponsorship, and we have a little message for you right now. Thanks again to GeoPeer for their sponsorship of today's GeoStrata Extra. And now to introduce our speaker and to ask some hard-hitting questions about the article that we're going to talk about today. It's GeoStrata editor Chris Woods.
Brad, how you doing?
I'm pretty good. You got to be good now. You got to be on, man.
Well, I'm good. I mean, hard hitting. That's exactly what we plan on doing here. Let's be honest. Well, I appreciate the invitation. Thanks again for having me back. To everyone out there, good afternoon. First off, as we come off Father's Day weekend here, hope all the dads that are watching had a nice relaxing weekend, because with school winding down for the most part for everyone, and all the children now being home, there's really not any instance for the rest of the summer where you actually be able to relax. So as we move on as Brad mentioned, the June-July edition of GeoStrata recently hit newsstands nationwide. And so once again, we're here for GeoStrata Extra. As Brad mentioned, my name's Chris Woods. I'm with Densification Inc. here in Virginia. And I'm happy to be back as host as we continue on with our GeoStrata Extra adventures. Today, I'm going to be speaking with Andy Boeckmann with Dan Brown and Associates in St. Louis, Missouri. Just to set the stage a little bit, as a whole, designers, engineers, constructors face challenges every day, right? So that's what makes our jobs and careers what they are, overcoming these challenges. Some of these challenges, they're related to what we studied in school: how to make buildings taller, how to make bridges wider, how to make dams and levees stand up to stronger storms. The flip side of this is that there's also challenges we face that have absolutely nothing to do with what we studied in school, right? Economic challenges, from higher interest rates leading money to cost more to borrow, puts pressure on project budgets. Inflation causes costs to rise across the board, also putting pressure on project budgets. And then on top of the economic challenges, all of us can relate in this industry to this, but nothing's ever on time. All you got to do is ask the developers we work for. I mean, I just put a crane on a site this past month. I was in there a month earlier than the schedule called for, and I still was told I was late, right? But I digress. As an industry, the foundation construction industry in particular, what do we do with these challenges? Well, we innovate, as we always have. Need to save time and money? Well, that's generally the focus of this current June-July issue of GeoStrata, which focuses on accelerated construction and foundation reuse. As part of this issue, Andy penned, or more likely in 2024 typed, a commentary piece titled, "Why Rebuild It When You Can Reuse It?" that delves into the rapidly expanding segment of our industry that focuses on, you guessed it, the reuse of existing foundations. So before we get started, I suppose I owe a proper introduction to our guest here. Andy's an engineer with Dan Brown Associates in St. Louis and Chicago, as I mentioned. Prior to joining Dan Brown, Andy worked with URS in between finishing his master's and his PhD degrees from University of Missouri. He works on foundations for large bridges, drilled shaft specialty topics, including mast, concrete integrity testing, and geotechnical research. More recently, Andy's become the newly minted chair of DFI's brand new Foundation Reuse Committee. And for those joining us today, I'll just go ahead and speak for him and say he would love your help on that committee. So just one quick reminder before we get into it. If you have questions, we got the chat feature there. Put them in. Brad will make sure I get these questions, and we will work to get them answered throughout the course of our discussion today. So with that, we're going to get into it. Andy, how are we doing?
Good. Thanks, Chris. Thanks for the introduction. Thanks to ASCE and to Brad for having me. I'm always eager to talk about foundation reuse. So
excellent. Well, I'm glad you could join us. I enjoyed working together with you on your article as an editor. It's one of the great things of working on this magazine. Every issue is different, and every issue I feel like I'm learning something new, and this was no exception. So, as Brad mentioned, this is a very hard-hitting, program that we do here. So these questions, I hope you're ready for them, right? Let's start with some of the overarching themes when it comes to foundation reuse, right? Based on your work in this area, can you maybe walk the listeners through what the most common applications for foundation reuse might be? Like, is it predominantly public sector infrastructure that you're seeing? Is it private sector buildings? Is it something else? Can we walk through that to start off?
Yeah, good question. I wish I had a precise answer for it. The problem is there's no one requires you to tell everyone when you reuse foundations. So I suspect that we probably reuse foundations much more than we're aware of. So actually, how I first got into foundation reuse was about 10 years ago. NCHRP, the highway group that does all the highway research that all the state DOTs contribute to, they did a synthesis study where they kind of we survey all the state agencies about different topics, and one of the geotech topics for that year was foundation reuse. And it was kind of getting to this question of how often is reuse happening and what are the different practices for it. So that study was one of the only ones that's really quantified how often reuse is done. Yep. And what that found is that for bridges, it's done. There's some agencies that do it all the time, and they tend to be like Massachusetts agencies that have a lot of urban areas.
Sure.
But there are a lot of other agencies that aren't doing it near as often. I suspect that the building sector does it a lot more than the transportation sector. just because they tend to be rebuilding in areas where they don't have a choice but to reuse the foundations.
Yeah, right.
There's also I don't want to wade too much into the details on question one, but for bridges, there's a lot of technical things that can kind of impede reuse. I mean, kind of the simplest is just that for a bridge, you've got to get from point A to point B, and there's so many stops along the way where you can put foundations. If you want to reuse your foundations, you're really tied in. You're putting a lot of constraints on your superstructure. The same thing doesn't necessarily happen for a building. So I think buildings have it a little bit easier in that regard.
Fair enough. Well, my experience with this topic's pretty limited. Where I've seen reuse occurred, it's been primarily with deep foundation elements, and mostly piers, waterfronts, or like you said, some buildings, like building expansion or something like that. You're trying to maybe reuse some elements that have been put in place. Is that a fair assessment of the majority of this stuff? As an industry, are there other applications that maybe just the general public that we're not aware of? You've seen it, like, have you seen it with like shallow foundations, retaining walls, things of that nature?
Yeah, good. I think shallow foundations are that's among them the easier applications of reuse.
Mm-hmm.
There's not quite as much of an uncertainty as with the deep foundation. With the shallow foundation, you can most of the time you can look at it. It's pretty easy to investigate the whole thing. You can core it if you want, and
sure.
There's just not as much risk, or at least not as much perceived risk as with the deep foundation.
Right.
So
yeah, you could do a boring next to it and make sure that it's sitting on something good. Whereas maybe with the deep foundation elements, you're possibly trying, like in some capacity, trying to test everything.
Right. With the I think that's one of the most fun parts of reusing deep foundations, that it's not fundamentally different from the design process for a new foundation. It's just that every step along the way is a little bit harder, a little more interesting.
Right.
So shallow foundations, I think, are a pretty ripe target for reuse. And of course, reuse doesn't mean reusing exactly like it is. You can reuse your shallow foundation and strengthen it with make it a little bit bigger, or maybe you're adding deep foundation elements. Right.
Okay.
Densify. I don't know.
Yeah.
The retaining walls, I'm not quite. I haven't heard about reusing. I haven't really given that much thought. That's an interesting question. But I think kind of the same thing applies, where you don't have the same concerns about like corrosion and stuff, because you can actually see the retaining wall. So that, except with some of the MSC wall straps, I suppose there's some concern about.
Got it. Yeah,
I
when I come up with these questions, I'm trying to cast a wide net, right? Like my goal is, like, especially if it's topics that I don't know much about myself, right? Like I have to assume that there's plenty of people watching us that maybe have not had the experience with this. So really, it's just trying to, give the biggest picture, or the best possible picture of what we're talking about to the probably, I don't know, somewhere, Brad can confirm, but probably millions of viewers we have right now. Let's stick on the topic. So you mentioned bridges, right? One of the articles in this issue outlined reconstruction of a bridge over the Ohio River between Kentucky and Indiana. And so as I was reading through it, there was a lot of really interesting points that maybe, okay, fine, we're talking about, like, you have a foundation for a building or a bridge, you tear down the substructure and you're putting up another structure, right? But this article got into a lot of the, like, ancillary benefits, right? Like, if you construct a bridge along the same alignment, you have less construction of approaches. You have less time and money spent trying to acquire right-of-ways that maybe weren't, or adjacent to where you're trying to build. So, can you comment on some of those secondary benefits from, like, the, schedule and cost standpoint that maybe don't immediately come to mind for people?
Yeah, the secondary benefits, I mean, in a lot of ways, are really the primary benefits, I think, for most projects, because I mean, the cost savings can be huge, of course, but I mean, at the end of the day, the cost of the foundations of it's a significant but not huge part of the cost of the overall structure. So reusing the foundations, if you just look at the direct cost savings, it's not going to be might not be a game changer. But when you think about, I mean, with that the bridge over the Ohio River, with when you've got hundreds of thousands, if not millions, of cars passing over a structure every day, and you're rerouting them, what an hour or something. I mean, the indirect costs of that are enormous. So for these agencies, saving a few $1,000,000 on the foundations is great, but if you're saving indirect costs to the publics of hundreds of millions of dollars, that can be huge. So
I think that article, I could be wrong, don't hold me to it, but I think they said something where, like, if it was just a complete tear down and rebuild, it would be like a 54-mile detour or something like that, because there's not that many bridges across the river in that part of the country, right? So that adds up for sure. Some of the articles in this issue, piers, other pile supported structures, there's often the structural elements where the existing deep foundations are, again, as we've been talking about, targeted for reuse. And again, you're looking time, money, all these straightforward benefits. Can you walk us through maybe what the steps might be to evaluate the condition of these foundations? Like right, everyone knows you drive a new pile, you put it in the ground, and you're, if it's a driven pile, you're driving it until you get your certain blow count based on what you did with your test pile program. But this is a whole other thing. So can you walk us through some of those steps that go into, like, evaluating what's good for reuse?
Yeah. So I think, like I mentioned earlier, why I think reuse is so fun from an engineering perspective is that it's the same kind of process we do for a new foundation, but every step of the way is a little bit more tricky. So starting out, you've got we always start out with a desktop study. You're looking at Google Earth and trying to figure out where you are. Now you've got to try to figure out what's in the ground, what foundation's there already. So you're looking through old historic records, trying to figure out if you can hopefully find plans, hopefully find as-built plans. So that's kind of at the beginning. Then if we move on to the next phase where we're going to do our site investigation, our site investigations should be considerably more involved, because we're not just testing the soils now. We want to do some kind of tests of the foundation that we want.
Foundation elements itself, yeah.
So, and there's some efficiency there too. If you're going to do, for an example, a parallel seismic test to figure out how long the existing foundation is, well, now you've got you're going to either do a boring or a CPT to do that parallel seismic test, and then you're getting site information too. So next step, then you got to you use that site information to do your design. So you're basically doing a capacity evaluation just like we would for a new foundation, but you've got to apply it to the existing foundation too.
Right.
So try to estimate the original capacity, and then if you need more, then you're designing new elements to go with it, retrofit, that kind of stuff. The big thing that we have to do that we don't have to consider with a new foundation is trying to estimate the service life of the remaining service life of the existing.
Yeah, no, that's a good point. Yeah.
And then our job's not done once the plans are put together. We've got to be on site. We should be on site for construction of new foundations. That's not always the case, but definitely when we're reusing a foundation, we want to put the old Trizagin-Peck's observational approach to use. We always want to be there to try to verify the assumptions that we've made during the design phase. So maybe we're doing a load test of the existing foundation once the construction's underway. That's kind of the best case scenario.
Yeah. Sadly, that Trizagin-Peck, observational approach, it happens to be the one place where most owners love to try and save the money, right? Because the observation. Yeah. So I will never understand that, but that's an entirely different episode altogether that probably involves scotch.
No, it should be every episode.
So with this, what's think back, I'll put you on the spot with this. What's the most innovative assessment approach you've seen, right, when it comes to something that's existing, and how are we going to figure out if we can use this?
So I mean, yeah, that's a great question. There's almost always some sort of innovation, whether it's on the investigation side or the design side. There was a great bridge example from Canada where they reused big pile groups for
Hmm.
from an existing twin structures, and what they did was they actually tied the two caps together, which they put big anchor bolts through tied through the two caps to essentially double the size of the pile cap. Which, if you think about from an overturning perspective, that makes your moment capacity go way up. So just by
Right.
Relatively simple retrofit, you're really improving your lateral capacity without even putting any new elements in. So that's
All
one
right.
that comes to mind from the design side. There's all kinds of innovative things that can be done from the investigation standpoint in terms of different parallel seismic, which isn't necessarily that innovative, but we don't do it all the time. So it's always cool to
Yeah.
see to verify foundation depths or figure out different foundation depths based on using the parallel seismic test.
It's almost like some of this stuff gets into like what you would think of like when there's failures, right? You have to go through some of these forensic examinations of things, and it's kind of that same mindset where you really get to what are all the things that could go wrong. I mean, you brought up a great point before about serviceability, right? We put a steel pile on the ground now, you can make some assumptions as to how long it's going to last, but if it's already been there for 30 years, well then, right? So yeah, that forensic piece of it is definitely something that's pretty interesting.
Yeah, it's the thing that tends to kill most reuse projects, I think, is from a technical perspective. There's lots of administrative, contractual things that can kill it, but from a technical perspective, the biggest hangup tends to be, oh, well, what kind of condition is this thing in?
Right.
And I don't know. I mean, it's an understandable concern, and it's hard to counter in a lot of cases, but I also think some of those concerns are overblown. I mean, if you think back to your Saturday morning cartoon days, what do you, if you have something you want to protect forever, what are you going to do? You're bury your treasure. It's the ground is a pretty safe environment compared to superstructure elements that like for roadways where we're throwing salt on them and doing they're exposed to all kinds of weather conditions. Put something underground, it's generally pretty well protected from environmental degradation. There are certainly exceptions to that, but in the most cases, I think it's a good environment to protect something.
Well, I mean, let's stay along these lines for a second, right? Because this is, we're starting to kind of flirt with that concept of risk, right? Like, what's an owner willing to take, not take? Look, especially with us as the foundation guys, right? I mean, we may have some structural engineers on here, and I'm not looking to offend anyone, right? But like steel, concrete, wood, right? These are materials that have relatively predictable behavior to them, right? That are above ground. The below ground stuff is this is all what we do. We're trying to make our best guess, and so with everything we do, there's risk, whether we're the engineers, the contractors, and the owners are really the ones that are kind of tasked with assessing how much risk they're willing to take based on the input from their consultants. So, on jobs where, in situ testing, ground conditions might, and, representative sampling of the existing foundation elements, the things we're talking about here, what do you see as maybe some of those biggest risk items that need to be overcome, or that, like you're talking about, could be a job killer? What are those specific risk things maybe?
Yeah, I think the risks for a reuse project, I would argue that it's not necessarily that they're greater than a project with a new foundation. They're just different. I mean,
Okay.
I mean, we're a risky business no matter what we do. I mean, you want to build a 12-foot diameter drilled shaft. I mean, that's not without risk.
Right.
So
no, that's fair.
I think reuse can be a good way to minimize construction risk in some regards. and a lot of, you mentioned steel, wood, and concrete being relatively predictable materials compared to our soils, for sure. That's absolutely the case.
Right.
So if you've got a foundation that's been in the ground doing its job for a long time, a lot of the performance risk associated with the geomaterials, that risk has already is reduced a lot because you've got
sort of been addressed already. Yeah.
Right. Yeah.
No, I mean that's certainly a good way of looking at it as well. It's an interesting question to me because this concept of risk, it's, as I now sit on the contracting side of things, a lot of times the owners of projects want everyone else to maybe assume the risk, right? And so it's how do you go about assessing, where those sort of dark corners are, right? I mean, it's a lot of what we do is risk management,
Right. And so there, I deflected a little bit. There certainly are risks with reuse. I think but those risks are, they're really a function of how much information we have. So if you're going into a reuse job, and I literally got asked about one 2 days ago where they don't know what kind of foundation it is. Well, yeah, that's pretty risky. I mean, if you literally, you can't tell me if there are driven piles underneath that footing there, then yeah, I mean, we're going to have to do a lot of investigation to address that risk. But if you've got really detailed, good installation records, which unfortunately isn't always the case, which will bring us back to our Scotch and our observational method. Then basically, so if you want to reuse, you've got to get to a good level of information, either through documents and records, or investigation in the field, or some combination thereof.
Yeah, no, and it can really span the gamut. I mean, I think back to early in my career, there was a timber bulkhead relieving platform scenario down on the Delaware River, south of Philadelphia. And to your point, this thing was built like probably 150 years ago, right? And so we were designing a steel sheet pile wall that was going to go in front of it because it was at an oil refinery, and all this product is flowing out into the Delaware River, right? And it was like, well, how are we going to rely on this timber structure that's there? So we're digging shored test pits, in confined space entry stuff with harnesses down underneath, trying to take little cores that were pulling the cores out of these timber piles and putting them in McDonald's straws to seal them up, to send them to a lab. And this woman, Colleen, that was the environmental lead for the project, comes out to the site one day to see what we're doing. And I'm down hanging underneath a relieving platform with McDonald's straws in my hand. It's just kind of what the hell are you guys doing? It's well, there's no information here. This thing's 150 years old. You gotta figure out what you gotta do here, So it can get interesting for sure.
Yeah. The Dutch have come up with all kinds of good methods because they've got everything over there is on really, really old timber piles that they've reused time and again, and they've got lots of good investigation techniques over there. So
that's good to know. So let's shift back to your commentary for a second. To me, as we work through it, and I producing the article, and as I reread it over the last couple of days, to me, the main takeaway is that right now, where we stand in 2024 in the industry, is that the lack of guidance on reuse of foundations really seems to be the biggest hurdle that exists in our industry. So what have you seen the industry doing to address this, and what are the next steps here?
Yeah, absolutely. That's that was really what I was I'm glad you got. That was the takeaway message I was hoping to get across. So that's good. In terms of what the industry has done, I think Federal Highway's done a good job. They've been leaders on this in this front. They put out they had a research team from New York that did a great report that's pretty easy to find online. If you Google Federal Highway Foundation reuse, I'm sure this will come up. I think it was published in 2018. Good. It's not necessarily a guidance document, but it is pretty comprehensive, kind of state-of-the-art review document. So Federal Highways helped, and then really this is you mentioned the DFI, our Foundation Reuse Committee. That's that's our committee's kind of biggest effort right now, is to develop a guide spec. So it wouldn't necessarily be a guidance, a comprehensive guidance document. It's intended to be kind of well, two things. One, a bridge toward a guidance document. That my goal is to put this out relatively quickly, as compared to a comprehensive guidance document that might take years to write. I'm hoping we can get this guide spec published quicker. But it's also something that agencies, owners, could take this guide spec, and then they can modify it toward their kind of typical reuse application. And then it'd be a place for them to start, and a good, I think it would really help manage the risks associated with foundation reuse.
So let's stay on that for a second, right? So as the first task with the Foundation Reuse Committee, so this guide spec, let's dive into that a little bit. Like, what's the overall structure of that look like? Are you talking about giving some guidance for, again, things we've talked about over the last few minutes here? Subsurface investigation? Is it testing of elements? Like, what do you have in mind in terms of what this sort of spec generally looks like in terms of what it's covering?
It sounds like you could be on our little subgroup, because you've got it in mind already. Yeah, it's basically.
Well, it turns out in my line of work, there's not a lot of reusing anything with dropping a 20-ton weight on it. Otherwise, I'd be happy to help out, right?
we'll take help from anyone we can get it from. Yeah, so the spec will be, so it's intended to be a design spec. So this isn't about the construction parts of things. This is really, so think, like the, whether it's the LRFD, AASHTO's LRFD design spec, or some other, so it's really intended to address all of the aspects of design. So kind of like I mentioned, the planning, subsurface investigation, capacity evaluation, condition assessment. Those are kind of the broad headings that we'll have in this guide spec. And also, it's not going to ignore construction by any means. That's kind of the last step, is what kind of observational things should you do during construction.
Got it. So to give a completely just gratuitous plug here, if people that are watching and listening were interested in getting involved in that committee, where do people need to go to get involved here?
Yeah, so you can send me an email if you go to DFI's website and go to the Foundation Reuse Committee page, which is pretty easy to find. There's a link there to join the committee. And you can
I feel a little like I watch Jeopardy every night with my daughter, and I felt like Ken Jennings right there, right, where they have like the video set of questions where it's like a complete cross promotional thing for like some new show that's coming on ABC. So I'm trying to learn from watching Ken Jennings right there.
We're all friends here.
That's it. Let's go back to the guidance for a second. Stay on that. In your commentary, you talked about structural engineers maybe not wanting to do stuff that isn't generally codified, which frankly is fair, right? We don't want to necessarily head out off of a long walk off a shore pier kind of thing without having something to kind of hang our hat on, right? So as foundation reuse continues towards maybe a more mainstream setting within our industry, where do you see the most important pieces for structural engineers and geotechnical engineers to be collaborating on this issue?
Yeah, that's good question. That's really the intention for developing guidance. I think, like you mentioned, structural engineers want to see stuff codified, as they should. I mean, that's we don't want to tie foundation engineers' hands too much, but
sure.
There should be some accountability. So I think that I think it's our job as the foundation engineers to really kind of work with the structural engineers. It's incumbent on us to kind of help them get to where we are on foundation reuse, because that's it's so we really need to pitch it to them, I think, and then for them to express their concerns to us, and we worked to address them, I think.
Yeah, and I mean, some of the things we've talked about now, like for instance, again, I'll bring back the serviceability concept, right? I mean, that's something they could probably put, how to expect, degradation of concrete or steel over time and things like that. I'm sure they have some opinions they'd be able to offer towards some of those aspects of what we're trying to do here.
Yeah, and just I'm having an open mind, not and I think that's why the guidance document will help with that. And the other thing that our committee has done is put out a number of case history.
Okay,
they're
sure.
like kind of 2-pager documents, nothing that take too long to look at, but just really trying to show, hey, this is feasible. You can hear some really cool examples where it's been done.
Yeah, general awareness.
Yeah.
Yeah. Okay. So new approaches, and it doesn't matter, ground improvement, deep foundations, soil mixing, whatever it might be. New approaches always drive innovation in our industry, right? So given the very, very real need to understand capacity of these existing foundation elements with a relatively good amount of certainty, are there new technologies or approaches that you've seen developed to this point, that are specifically sort of coming out of this trying to reuse foundations, and if so, are there these innovations, are there areas where you could see them having a broader impact on our industry in general?
Yeah, I wish we were that important. Or that I think it kind of tends to work the other way around, where there's technologies that are developed that we should be applying, that we can apply with a little bit of tweaking for reuse. Like I mentioned, the parallel seismic test.
Yep.
So that's one of the best ways to verify or investigate the length of an existing foundation element is to so you go out and you're going to have an instrumented hammer and bang on your pile cap, and then you'll have adjacent to the pile cap either a seismic cone or a case borehole with accelerometers, and you're going to be listening for the waves to come off that pile. So that's parallel seismic wasn't developed because of foundation reuse in particular, but it's something that we should that reusers can take advantage of.
Yeah.
And same as load testing. We load test new foundations all the time. We can with an existing foundation, it in some respects it's a lot easier to load test because you've got a reaction system built in. You go out and you expose kind of the top portion of your pile, you cut out a segment of it, stick a jack in, and then your reaction force, rather than having to build a new reaction beam and put in reaction piles, you're just pushing up against the existing structure. And obviously there's a lot that goes into that, and it's you're not going to be able to do that every time, but it's been done a lot and to great effect.
Well, let's stay there for a second. So like one of the things I haven't asked, so when we get into like load testing and stuff like that on these types of projects, is it, you may do, brand new pile foundations. You're going to come down, come out, drive a bunch of index piles, and then you're going to select which ones you want to do your load test. There's generally, guidelines as to how many you want to test. Is reuse generally fall in the same, percentage wise, you want to load test the same amount of elements, or because some of these may be existing and you're trying to get a higher level of comfort, like, do you see that there's more testing done, or perhaps like to your earlier point, look, these piles have been here working pretty well for a long time. Maybe we test less than we would on like a brand new pile job. Like how does that generally work?
I'm going to give the common geotech answer of it depends.
There it is. I love it. I love it.
So it depends on the uncertainty. It depends on how much the site conditions may change from one place to the next, the level of confidence you have in I guess the sameness of the different pile groups. And also you might test one and realize you've got way more than you expected. So we went out and did this for a couple of MoDOT bridges where the plans listed, X number of tons for the pile capacity. And for 2 bridges, we went out and load tested one pile at each of the bridges, 2 different types of, one was concrete piles, another was steel piles. And for both of them, we couldn't fail the piles. We got up to 6 or 7 times, the capacity that was listed on the plans, and we still hadn't failed the things. So I think in most cases, there is a lot of reserve capacity in our existing foundations. It's not always easy to load test them, but man, if you can do it, I think there's a lot of benefit to be had.
Well, that's interesting. I mean, do you suspect that something like that, right? Because unless you're putting a pile, sitting dead on the end of rock where you're not even really worried about any sort of sleeve resistance. I mean, do you suspect a scenario like that is just there's been buildup of strength over time and maybe that area that was disturbed? Or do you just think maybe if this pile was put in 100 years ago, these dudes didn't have the technology available to them to really push the envelope in terms of testing? I mean, it could be a combination of the two, or what do you think?
Yeah, I mean, it's I think it is a combination. I think probably the biggest reason is that those original estimates were so conservative. I mean,
Right.
They didn't know what they were. I mean, they're designing based on the E&R formula, which had I think
Right.
it was a built-in factor of safety of 6, and then they go out and probably more often than not beat the hell out of the pile to put it in more than they needed to. And so yeah,
Right.
and that's great. We should take advantage of that. I mean, the bottom line is it doesn't matter what the cause of it is. We're engineers, so we want to know why it,
Yeah.
is it set up, or is it, what's the explanation? But who cares? Let's take advantage of it.
Let's use it. Yeah, no, that's fair. That's fair. Let's shift for a second, right? We've talked about testing, we've talked about guidance. When we talk reuse, though, it very clearly implies that less materials are going to be needed, which is fantastic from an environmental standpoint. So if we think about like the LEED rating system and green building movement, things like that, is there pretty concrete incentives already in place that there could be benefit to a project that's able to incorporate foundation elements at this point?
That's an awesome question. I've never thought about the LEED perspective.
Right.
That's going to have to be a committee discussion point. That's if there's not, there should be. I don't.
Yeah, you would think, right?
Yeah.
I mean, we talk carbon footprint with a lot of stuff. Well, you're
right.
You're reducing a pretty significant carbon footprint being able to reuse a bunch of stuff.
Right. So I know, like in London, I think or the UK generally, there's a lot more regulation on the carbon footprint side of things. And my understanding is I think there's some rules, or they might not. It might be carrots rather than sticks, but I think they do take advantage of reuse in that kind of framework. I'll also say that London, just in general, the reuse that's happened there because of really high property values and things that have been rebuilt 4 times already.
Well, that's it, right? Let's talk longevity there, right? Like we're we think we're old. We've been around for 200 years here. Like they've been building stuff over there for millennia.
Right, and so some of the coolest examples, especially actually the article that was in GeoStrata that the Arab folks, Dinesh Patel and Henry and Hillary wrote, it's fantastic. The examples that what they've done over there is really, really impressive.
Yeah. Well, geographically, so let me start. We got our first question that's come in from Jeff Rains asking, the California building code requires testing of deep foundations for reuse. So do you have any specific experience with the California building code you can expound on?
I do not.
Okay.
I'm not familiar with the California code. I'm not sure if the testing is if it's like integrity type testing or load testing.
Load testing. Okay. Yeah, it could be different. All right. No, that's fair. Trying to. Brad, I don't know if we have many other questions come in. This is the one I've seen so far. I find this to be a very, very interesting topic. you know, and why we're getting ready to wrap up here, you know, if anyone else that's out there watching, if you got any last minute questions you want to put in here, go right ahead. But you know, I appreciated you know, working with you on this article. I've definitely learned something, and you know, now with us both being you know, new committee chairs with DFI, I know you're looking to kind of take this head on and run with it. You know, before you know, just while we wait another minute or two to see if any other questions comes in, you know, as we get ready to wrap up, is there anything that we haven't touched on that comes to mind that you'd like to mention with this?
Oh boy, so I've already plugged our guide spec development.
Brand new committee again, you know, on the DFI website. You could go join the committee. Go right ahead.
Well, and I'd encourage everyone to read some of those examples from the GeoStrata if you haven't already. There's some great ones in that issue, but there's a lot of other great case histories out there. And if anyone's got any good, I mean, you know, I mentioned at the start of this that we don't have a great, we don't track all the examples of reuse. So I'm sure there's tons of great examples out there that I'm not aware of. I would love to publicize them, and that's one of the things I'd like our committee to do is kind of get a kind of a repository going of all these good examples. And there's, you know, probably people out there listening who could come up with much better answers on the, you know, innovative techniques that they've used. So I'm all ears.
Well, look, man, I think you did a great job answering some of this stuff. You know, hopefully, you know, the folks out there listening, I think, if nothing else, can have a better understanding, at least on the surface, as to where this segment of our industry is going. So, again, you know, I appreciated working with you on the article. I appreciate your time today. Brad's rejoining us. So, Brad, I don't know if you want to wrap us up.
Well, I don't always want to, because sometimes the discussion is really good, and you guys did a great job today. That was a lot of fun, and this was such a cool topic. I was really, you know, it's funny. I don't know how many people realize this that are watching. We choose the issue themes like a year and a half in advance. It's a long lead time, and the articles start to be written usually about, I think, maybe 8 months before the issue comes out. Sometimes even a little earlier. So to see the things actually come out and to see it in print, I mean, honestly, sometimes I forget about it before I see it. And this is one of those cases. When this issue came out, I was pumped because between the topics that were in here, your piece, Andy, the I-95 reconstruction project, I mean, there's a ton of good stuff in this issue. So everybody should
absolutely.
You know, Chris said it's available nationwide. It may not be in your local Barnes and Noble or Books A Million, but you can always check it out at readgeo.com.
That's it.
So for all the viewers, yeah, I hope you liked what you saw today. For those who submitted questions, which was only Jeff, but we still say thank you to Jeff for submitting today. And thanks
Andy
to
did
everybody.
Such a good job answering the questions. There was none left. That was it.
And thanks to everybody who just showed up to watch today. We really appreciate that. 2 quick commercials here. Our next live stream will be a week from today, and it's the 150th anniversary celebration of the Journal of Geotechnical and Geoenvironmental Engineering. Kind of unreal that was being published in 1874. But here we are. It's been 150 years, and we've put together an amazing panel to talk about the history of the journal, some of the key topics that they've discussed over the years, and talk about the future of its place in the profession. So you will want to be here for that. You can get more info on Eventbrite. And then the next GeoStrata Extra. I mentioned that this issue was super cool. We don't usually do 2 GeoStrata Extras from one issue, but we made an exception this time. On July 11th, you can join us to hear from Archie Filshel and Teresa Laux. And there was a third co-author, and I'm really sorry. I can't remember who it was at this point. Chris isn't going to bail me out either. Their piece on the I-95 reconstruction in Philadelphia last year. You can find out more about that on Eventbrite as well, and all our other upcoming live streams in this GI Summer of Live that you are part of right now. Again, click like, subscribe, and get notifications if you liked what you saw. You're here at the end, so you probably did. Thanks for sticking around. We really appreciate it. Matt Roberts was our producer today. A big shout out, as always, to Jim Withiam for keeping us on track and making the magazine as great as it is. It wouldn't really be anything without him. So we have to give him a big shout out.
And just to bail you out, Majid Kabajian, that's the third.
Bam! Thank you so much.
Absolutely.
So tune in for that. We'll see you soon with another Geo-Institute live stream.